second Gateway Bridge, an icon for Brisbane skyline and a vital enhancement to the city's cross-river connectivity. At 1,627 metres long, the new 6-lane bridge features a shared pedestrian and cycle path and a main span of 260 metres. Constructed using a cast in situ balanced cantilever method, it will take 3.5 years to build, and when completed, it will join its twin as one of the top 10 of its kind in the world. The second Gateway Bridge is a key component of the Gateway Upgrade Project, a Queensland state government initiative being delivered by Queensland Motorways in partnership with the Leighton Abbey Group joint venture. Joining Leighton Abbey Group in the Gateway Bridge Alliance is VSL Australia, a world leader with a proven track record in the design and construction of balanced cantilever bridges. This second Gateway Bridge will be built 50 metres downstream of the existing bridge. It will be constructed on 17 piers, with 2 main piers located in the Brisbane River. When completed, the second Gateway Bridge will replicate its twin in size and style. Construction of the new bridge commences with test piling for piers 6 and 7, the 2 river piers. The test pile is built and fitted with instruments to confirm the geotechnical properties of soil and rock. Part of the Brisbane riverbed is dredged of soft silt material. A silt curtain is placed around the site of each island to avoid deterioration in water quality. Rock is pushed into the river from the southern shore to form one island. From the northern shore, a rock causeway stretches 120 metres into the river, and a second island is constructed. The 2 largest piers in the river each require 24 board piles. Board piling requires a piling rig and crane. A core sample is first drilled at the pile location. The rig and crane then work together, with the crane using a vibrating hammer to drive 12-metre lengths of hollow steel casing into the ground. Each length of steel casing is welded to the next, and the process is repeated. Soil inside the casing is excavated by the piling rig. The excavation is cleaned and a reinforcement cage lowered. Concrete is poured through a funnel into a trammy tube, which is withdrawn as the concrete level rises within the pile. The pile is now complete, with the deepest more than 55 metres beneath the riverbed. A 3.2 metre thick pile cap is constructed. Over 19 metres long and 17 metres wide, the pile cap provides a solid base upon which to build the piers. Twin blade piers are constructed independently of each other using a climbing formwork system. Cranes install and remove the external formwork panels for cleaning during the construction cycle. The internal formwork is connected to the external supporting frame, which is lifted by a hydraulic jacking system after the completion of each concrete pour. Once the external forms have been reassembled and reinforcement bars placed, concrete is poured and set to form the next lift of the pier structure. After 9 lifts of approximately 6 metres each, the pier is complete. Each of the main piers towers 54 metres above the ground. Pier heads are constructed as the starting point for balanced cantilever construction. Each pier head takes approximately 3 months to complete. A platform is first assembled at ground level and crane lifted into place. The pier head, a massive structure with walls over 5 stories high, is constructed at height using concrete pumped from ground level. Upon completion of the pier head, form travellers are crane lifted in pieces onto each main pier. They are assembled at height, ready to construct the 260-metre long balanced cantilever main span and each of the 130-metre long side spans. A cast in situ construction method is used for the main span superstructure. This involves pumping concrete from ground level into formwork for each twin box girder segment. After casting the segment, the form traveller is jacked forward on rail beams using hydraulic rams in preparation for the construction of the next segment. Each segment is pre-stressed using tendons of high tensile steel strands. Pre-stressing is a key element of the structural design. At each of the main pier heads, the twin box girder segments are 15 metres deep. Mid-span, the segments are 5 metres deep. It will take about 12 months to complete these spans. Construction of the northern and southern approach spans occurs in advance of the main piers. The 750-metre-long northern approach requires 10 piers for support. The shorter southern approach, 350 metres in length, requires 5 piers. Using a piling rig and crane, octagonal piles are hammer-driven into soft soil on the Brisbane River's northern bank. Each pier is founded on approximately 45 piles. When piling is completed for each pier, pile caps 2 metres thick take shape. After being cast below the existing ground level, each pile cap is covered with soil. As with the piers in the river, piers for the approach spans are constructed using climbing formwork. As the pier grows, the formwork is raised. Approach piers range in height from 15 metres to 47 metres. Pier heads are cast in situ at height. While smaller than those on the main piers in the river, these pier heads also act as the starting point for the construction of the balanced cantilever approach spans. The pier heads must support the 800-tonne overhead launching gantry used in construction of the spans. In late 2007, the launching gantry arrives at the northern bank of the river. After assembly at ground level over several months, the gantry is lifted into position at piers 14 and 15. Strand jacks and lifting frames on the pier head segments assist in raising the massive structure. After commissioning, the gantry is ready to construct the precast concrete approach span using segmental match casting units. Twin box segments for the approach spans are made to measure at a precast factory. Segments are lifted into position by heavy-duty mobile winches, vital to the workings of the overhead gantry. The segments are installed either side of the pier, so the overall structure is never more than one segment out of balance. The balanced cantilever for a span is completed by installation of 48 segments placed either side of a pier. The end of the new cantilever is stitched to the end of the preceding one using cast in situ concrete. Once the northern approach is complete, the gantry is disassembled, demobilised and transported to the southern bank of the river. The process is repeated for construction of the southern approach. Each span is stitched together to form a single, solid structure to complete construction of the second gateway bridge. Mirroring its twin, the bridge stretches cross-river in near-final form. Ship arrestor islands, designed for collision protection, are constructed around each of the 4 river piers of the gateway bridges. Pavements are laid and line marking completed. Urban design features are fixed, including inclined screens and graciously shaped light poles designed to harmonise with the bridge's curves. Its twin is treated with similar attention. At each approach, the landscape design in the form of terrain wave sculptures will complement the uniqueness of the bridge structures. One bridge is now dedicated for northbound traffic and the other for southbound traffic. Motorists crossing the bridges will experience a reliable free-flow traffic environment with the introduction of a fully electronic tolling system. The twin gateway bridges are complete and ready to service southeast Queensland. 157,000 tonnes of concrete, 11,600 tonnes of steel, 473 piles, a 300-year design life, 200 workers, 20 stories tall and 3.5 years in construction. A significant landmark, the twin gateway bridges tower 64.5 metres above the Brisbane River and stand accentuated against the Brisbane skyline, an achievement in design, construction and delivery.